Oxygen Blast technical seminars are an Intertech production. For instructor-led .NET, Java, and XML courses, visit us at www.intertech.com.
Okay, the first thing I want you guys to all be aware of is that all the action is happening in this subroutine. There is no extra method in my class that I have to point to. Because now when I call find all, I can just inline right here what normally I would have to specify in a secondary method, like we saw right up here. Yeah, so check it out, right? Instead of having to define this named method, I can just simply inline it now. So the short answer is, anywhere that you find a method that says, hey, give me a delegate object as a parameter, I can now substitute the delegate object with just a fitting lambda. So how do we construct a lambda? Well, you can see that I'm just going to use the function or possibly the sub keyword. So if I wanted that to be a subroutine, I would just have to replicate it throughout here. And then of course I wouldn't have a return value anymore. Okay. But here I said I want a function because we are definitely going to get back a return value, right? See that find all method, remember he wants a predicate, right? So he says I can point to any method that returns back a Boolean and then takes a type parameter as an argument. So we get a lot of compiler inference here. Like when I say function s, well, the compiler knows that s has to be a string. You can see that through the IntelliSense. And it knows that because of the way I've configured my actual list. Back up here, right? We have a list of strings. So this lambda syntax is much, much more powerful than it was under 3.5. In the world of 3.5, you could not have lambdas that contained multiple code statements. They could only be for one value. And you also had to always use a function. You couldn't have a subroutine before, but now you can. Whoop, we'll get to that in a little bit later. Okay, so that is also a very, very nice change in the world of Visual Basic. Real support for lambdas. Okay, so that kind of covers the bulk of the big changes that took place in Visual Basic and C#. That was the previous video. I now want to kind of switch gears a little bit and talk a bit about some of the new APIs that we have under 4.0. And my favorite, by far and away, is this guy right here called the Task Parallel Library. This is basically a brand new approach for building multi-threaded applications. Now, if any of you have worked with multi-threaded applications before, you remember that there's a namespace in MS Core Lib called system.threading. And that's good, right? That was a pretty good toolkit. Nowadays, we have a brand new namespace in MS Core Lib called system.threading.tasks, right? This is kind of the heart and soul of the Task Parallel Library. Now, the reason that this framework can really simplify how we work with threads is that the CLR is going to be pulling threads as required from the thread pool. So we never have to directly create thread objects and configure them and start them up. When we use the Task Parallel Library, a lot of that kind of work is going to be handled on our behalf. Now, as it turns out, the Task Parallel Library, the API, is making use of many, many, many different delegates in the background. So those little lambda expressions are going to be even more helpful, right? That's going to simplify how we type up our Task Parallel Library code. So we'll talk about that first, and then I'm going to kind of complete this part of the discussion by looking at parallel link. And that is where we can build link queries that can now be distributed across multiple cores. So we get that parallelization in a link query as well. So let's go ahead and kind of begin here. Remember that we are looking at this new namespace, system.threading.tasks. The key class that you'll probably use a lot is called Parallel. Think of him as the guy doing much of the heavy lifting. Now here in this screenshot, I selected Parallel so I can show you a whole bunch of methods here which probably look pretty familiar, right? The for method. There's another one called for each. Well, the way that the task parallel library was designed, and in particular the parallel class, is that it becomes really simple to take a batch of repeatable code statements and run them in parallel. And what you can essentially do is you can kind of retrofit any for loop or any for each loop with a method call in the parallel class. And that's really great. I mean, it makes it just very, very simple to go ahead and get some multi-threading for free. Now, just because you can doesn't always mean you should. You know, the task parallel library has a couple of built-in optimizations where if it can kind of discover that your code could actually be slower, it might not actually spin up as many threads as you would think. And there's actually a whole part in the help system that will talk about, you know, kind of making choices on would this be a decent query to run in parallel. So if this topic that I'm going to talk about is interesting to you, make sure you look up TPL in the documentation and you'll bump into a couple of nice little reads there. But let me go ahead and show you an example. If you take a look at the methods of parallel, you're going to find that there are these two delegates that are used all over the place. One of them is a func, and the other guy is an action. Really simple, actually. What the func delegate represents is an object that can point to a method with a return value. So it's a function. Action is very much like a VB subroutine. It is a method with no return value. So that would be like a void return value in terms of C#. Okay, so we could use these delegates directly when we're working with the task parallel library, but you're probably not going to want to do that. It can lead to some pretty ugly code. So again, we're going to favor lambdas. So let's take a look at this code here. Okay. What I'm doing in this code is I'm looping through a collection of files on my hard drive. And they're all bitmap files, or JPEGs, I think they were. Okay? And I'm going to do some fairly labor-intensive work on the image data. I'm going to rotate it. And then I'm going to save it out to a new location on my hard drive. So if I had a folder on my hard drive that had maybe 500 photos, which is not unheard of, and if I were to execute the top code block, my application could definitely be hanging for a long time. Because that would be 500 image files that would have to open up, rotate the image data, and then save it out to a new location. Now, if I want to run this in parallel, look at how simple it is to do. Basically, I take what I've highlighted here in red, and I'm going to substitute it now for a call on the parallel.forEach. Now, this method has been overloaded a number of different times, but essentially it boils down to two key ingredients. It has to have an enumeration of something. So what's the enumeration of? Well, it's going to be all these files I'm trying to iterate through. Okay? And then it has to have a method to pass those files. So what am I really specifying? Well, I'm using a C# lambda, but behind the scenes, that's really breaking down to an action delegate. So that's pretty simple, isn't it? I mean, all I have to do is just literally get rid of my existing for each and plug in a call to parallel.forEach. And then I don't have this code loaded up, but you see I did a little bit of diagnostic work here too. So I'm just going to change the text of the window to show which thread is currently processing the request. Well, up here, I would just see the same number all the time because I just have one thread doing all the work. Here, if I set things up correctly when I call the method, I would see that number constantly flipping on my window because I would have these different threads that were operating on different image files.
For more free learning resources and to see the latest lineup of our instructor-led .NET, Java, and XML courses, visit us at www.intertech.com.